of you. You should have your circle book out in front of you. We're going to add a couple more notes to it. Remember, this circle book is important because you can use it on tests and quizzes. It keeps your notes all there. All right. So we're going to add a couple more things. One of the things we're going to add is stuff about internal and external tangents. Okay? So I'm going to draw a picture, and I'm going to ask you if you think it has internal tangents or external tangents. Okay. If I drew two circles, and they have, this is all about common tangents. And I'm going to draw two lines. Do we think those are internal or external?
External. I don't know.
Internal, they're in between. This is an internal tangent. Okay. So again, I've got two circles, and I'm drawing their tangents. What do you think these are? External. Okay. Can these two circles have an internal tangent, yes or no?
No.
Yes.
Yes.
Right there. That's an internal tangent.
Wow. We said internal tangent.
Okay. What kind of tangent can these two circles have?
Internal.
It has to be external. Because it's on the outside of both of them. This is in between them. You can't get in between these two. What about this? Does this have tangents?
Sure.
No tangents, because tangents have to be on the outside of a circle. So they have no common tangents. Okay, I think I'm done with tangents.
Okay.
All right. One more thing I would like to add. This is not about a tangent. This is something different. This is called a secant. It intersects the circle in two spots. Okay, let me ask you guys a question. If this didn't go through the circle but stopped at the edges, what would I call it?
Just a regular tangent?
Nope.
External.
No. Tangents only hit one spot. A chord. It would be a chord.
On the outside.
Chord, it would stop in two spots. Secant goes through it. Tangent only hits it in one place. Okay? Secant. Okay, we're going to look at your homework first just so I can make sure we can explain it. We have enough time for that. And then we'll spend the rest of the time working on our group assignments.
Is this the homework?
Tangent practice.
Janelle was trying to tell you something. I couldn't remember. And there's the one.
All right, shh. You guys, there shouldn't be any talking going on right now because I am not finished. And I'm still recording. Okay.
Oh.
So, we're given that AB is 17, BC is 18, CD is 21, find AD. You're going to use this equation right here, all set up for you that we put on our paper yesterday. Okay? Given ON equals 7, and MN equals 24, and N is a right angle, find O to Q. You're going to use Pythagorean theorem, and you're going to use that these are all tangents meeting at a point. Okay? So this is the new stuff. O has a radius of 8, and circle P has a radius of 13. Find the length of the common internal tangent. Okay, so let's do this. O has a radius. Circle O has a radius of 8, and circle P has a radius of 13. Obviously, these are not, 3. There we go. P is 3. O is 8. O to P is 13. Okay? We want to find the length of an internal common tangent. All right. So, let's talk about it. How do we know the length of that? What kind of things have we been doing in the past that you think we would be setting up?
I don't know.
I don't know.
An internal tangent.
So we've got our internal tangent. Okay. So, and we know the distance is 13. So, how long is between here to here? We know that's 13. We're looking for x. Do you see our right triangle start to form?
Yeah, I get that.
Okay. So we're going to end up with, we know, let me draw this a little bit differently. Okay. We'll end up with a triangle. I'm going to draw it kind of at the top. Where this is 13, I'm looking for this, but what is this height right here? I was going to draw this. It wouldn't be 8, it would be 8 minus 3. And you end up with 5. Okay? Because we want from here to here, and then we want a height that's left over to end up with that kind of a thing. Okay. Yeah. Because it says right here, O to P is 13. Okay. So now I'm going to go 13 squared plus 5. Oh, excuse me. X squared. 13 is the slant. I'm sorry. I drew it wrong. I'm looking for x. Because x would be the shortest distance. So 13 squared, the x squared plus 5 squared equals 13 squared. Therefore, x squared plus 25 equals 169. X squared equals 144. So x equals 12. So you're going to be setting up these right triangles for each of these. Okay, let's look at the back. Same kind of thing. All of these should be set up with some sort of right triangle. There is one that's a little bit trickier. But for the most part, that's what you should be doing. Okay. So now, guys, let's look at today's group assignment. All right. We want to find out point P is the center of the circle. BA is a tangent to the circle at point B. PC equals 2/3 BA, and BA equals 1 plus PB. Find the length of the radius of the circle. Okay, remember what kind of stuff did we use for these? Okay, so that's your hint for that one. All right, point B, P is the center of the circle. CD is 8 more than the radius of the circle. PB is perpendicular to CD. So perpendicular means it's what kind of angle? 90 degrees, right angle again. And AP equals 2 times AB. Find the length of the radius and the length of the chord CD. So once you find the radius, you should just be able to times it by 8, or add 8 to it, and you get CD. Okay? Remember, I just talked about a right angle, so you're going to be using Pythagorean theorem again. Okay? All right, number 3. Number 3 on the back. You know what? I'm just going to have you do 1 and 2 today, I think. I'm just going to have you guys do 1 and 2.
Can you cross out the back?
Okay. No, because we might use it later.
Oh.
So I would like you to do 1 and 2, and then I'm going to have you guys share out. Michael, can you join your back of your middle table? So go back back to your middle table. And you guys are going to work in groups. Okay? And then we're going to talk about our answers when we are done. Okay? All right, guys, get started.